Welcome to the lesson on sketching planes in 3-space in R3. Basically, the way I would think about the planes is whether or not the D is 0 or not in the Cartesian form. So we're going to be starting with Cartesian form. And if D is 0, it's sort of one set of cases, or I think about it one way. If D is not equal to 0, then I think of it another way. D equals 0 means the plane will go through the origin. When D is not equal to 0, it won't go through the origin. Okay, so we'll start off with what I think is easier. When D is not equal to 0, that means the plane is not going through the origin. So when D is not equal to 0, there will be at least one intercept of either the x, y, or z axis. There could be 2 or even 3 intercepts, depending on whether or not A, B, or C are equal to 0. So for this first example, we have the case where not only is D equal to 0, but B and C is are as well. Sketch the plane x minus 5 is equal to 0, often just written as x is equal to 5. So the values for y and z, the equation does not control them, so they can have any value at all as long as x is equal to 5. So there will be no y or z intercepts because the y and z intercepts happen when x is equal to 0, and x is always equal to 5. So that's the first thing to realize, perhaps. No y or z intercepts. And if you think about what the plane will look like when x is equal to 0, it'll be a vertical plane. And plane, the pi, right? Pi for plane, will be parallel to the YZ plane. And the plane will be perpendicular to the x-axis, okay? So that's sort of descriptive. Now, the x-intercept is 5 because x is 5 everywhere. So what I do is I would just sort of put a little tick mark on the x-axis, and I would call that 5. Great. That's the position of the plane. It goes vertically through that spot. So how do you sketch that? Well, you always have to show edges to every plane in order to see it. You think of a flat, perfectly uniform plane or sheet in front of you, it's really hard to see depth. You have to show the edges. The plane actually goes on forever in all directions. So, really it doesn't have edges, but we show edges so that we can see it. So here's what I would do to show it. You put the edges that you're drawing so that they're parallel to the Z and to the Y-axis. So, and then to make it look like it's in front of the origin and the Y and Z axis, you hatch it in, shade it in, so to speak, making it look three-dimensional and that it's in front. So that's the idea there. You can use a ruler if you want. I'm using a line tool. Actually, I don't like it that much. Maybe the next one I'll try freehand. Okay, so that's the first one. The second one, D is still equal to 0, but this time only C is equal to 0. That means we will have both X and Y intercepts. Okay, so let's describe this first. X and Y intercepts exist. No Z intercept. Okay, it'll never cross the Z axis. Sorry, I'm reading that wrong. No, I have that right. Sorry, no Z intercepts. This means that the plane, vertical plane, okay, the plane will be parallel to the Z axis, and the plane will be perpendicular to the XY plane. All right. So to sketch this, we'll start by finding the x-intercept and the y-intercept. So x is equal to 5. So I plot, I put a tick mark there. There's x is equal to 5. The y-intercept is when x and z are both equal to 0. And again, y has to be equal to 5. And so I'll put a tick mark there at that point. Okay, so I have the intercepts graphed. So again, we have to show the edges of the plane. And how do you do that so it looks right? Well, the way we usually do it is we connect the intercepts like that. And then we draw edges that are parallel to the x-axis. And the other edge parallel to that line connecting the intercepts. And then we shade it in to make it look like the origin and the z-axis are hidden. Here we go. There's the plane, x plus y minus 5 is equal to 0. Okay. Try the next example. Pause the video, give it a try. It's similar to the one we just did. See if you can describe it and sketch it. Okay. This will have an x-intercept when y and z are both 0, and x is equal to -4. There's the x-intercept. The y-intercept happens when x and z are both 0. And sorry, the z-intercept, my bad, there is no y-intercept. Sorry, the z-intercept when x and y are both 0, and z will be equal to -4. Okay, so there's no y-intercept. So the plane is parallel to the y-axis, and the plane will be perpendicular to the xz plane. Okay, so sketching this, it's a little more fun when the values are negative. So we'll extend the x-axis and mark -4. There we go. And we extend the z-axis and we mark -4 for z. Those are the intercept points. Now to sketch it, I'm going to connect the intercepts. And this is difficult because it almost looks like it will be in front of the y-axis, but really it's below and behind the y-axis. Okay, the y-axis and the origin are on this side of the plane, or closer to than the plane is. Again, we're drawing edges, and we hatch it in. Okay, so there you go. D is not equal to 0, so it's not going through the origin. 2 intercepts. Okay, we're going to go on to examples where there are 3 intercepts. Notice A, B, and C are all non-zero. There are 3 intercepts. X-intercept, y is equal to 0, is equal to z. So that'll be at 3, 0, 0. The y-intercept, x is equal to 0, and so is z. And that's at 0, 3, 0. And the z-intercept happens when x and y are both 0, and that also is at 0, 0, 3. This is a really simple case, I guess. So these are usually the easiest ones to graph overall, especially when the signs are the way they are. So we'll just mark out the intercepts at 3, 3, and 3. Okay. And connect them. So what you're seeing is the section of the plane that's visible in the positive x, y, and z regions, right? All 3 coordinates are positive. The rest of the plane is, behind the wall, representing the xy plane, the yz plane, and the xz plane, if you like. Okay, only that corner of the little triangular section of the plane is visible. Okay, once you've done that example or taking that in, give this one a try. Pause the video and then start it again when you're ready. So the x-intercept is at 6, 0, 0. The y-intercept is at 0, 4, 0. And the z-intercept is at 0, 0, 3. 3, 4, and 6. So, and it's, I'm not doing a scale. Please don't put tick marks on your axes. You can, but don't think that's sufficient. You do need to label. If it's an intercept in the axis, you don't have to give all three parts of the coordinate. You can just label a number, but otherwise, if you're plotting a point, you would have to give the coordinates. But not just tick marks. I'm not going to be counting the tick marks if I'm looking at this. You need to label the points. Okay, that's it. That's the last one when d is not equal to 0. Now we're going to deal with the cases where d is equal to 0. And these all go through the origin. That's one thing for sure. So you always have this. But notice in this first one, there's no z value. That means z can be anything. Okay, so this plane is vertical. The plane will be perpendicular to the xy plane. And the plane goes through the x-axis. So there are no, I guess I shouldn't say that. The origin is the x and y intercepts. So it's not really helpful to graph this. So we have to do something a little different. What we do is plot a point on the xy plane. So for example, when x is 2, what does y have to be? 4. And of course, on the xy plane, z is 0. So 2 and 4, right there, I plot a point. I'm not labeling those tick marks because they're not part of the plane. Just using them to sort of judge the proportion. Okay, so the plane goes through the z-axis and cuts through the xy plane along this line. Of course, it doesn't stop there. It would continue on, right? It would continue on down this way, but we have to show edges. So draw, starting at the z-axis, draw a line parallel to that line in the xy plane, and then we show the edge, a vertical edge, like that, and then shade it in. So if you like, it's like a plane that's hinged on the z-axis. So it rotates around the z-axis and it's locked in place by that coordinate on the xy plane of 2, 4, and 0. Okay, so if one of the variables x, y, and z are missing, then you know the plane is going through that axis, the one that's missing, and you need to plot a point in the corresponding plane that's perpendicular to that, so the xy plane. So if there's no x and there's a y and the z, then you'd be plotting a point in the yz plane, and the plane would go through the x-axis and so on. Okay, so try that. Pause the video and give this one a try. Describe the plane and sketch the plane. Okay, plane is and goes through the x-axis. The plane is perpendicular to the YZ plane. What else did I say about it, the last one? And the origin, of course, is the YZ intercept. I don't know, that's a big thing to say after the first time. So let's just go ahead and find a point on the YZ plane. So let's look at it's a multiples thing. If you want to have something that's simple, so 2 and 3, you can do multiples of 6, so 6 or 12 and that sort of thing. So keep it simple. We're doing in the YZ plane, so x is equal to 0. If y is 3, then z is equal to 2, and that works, okay? So 3 and 2, so right there is the point. And it is 0, 3, and 2. We join these two, and now we have to show a plane that is actually really difficult to visualize because it's on an angle and it's going through that the z-axis, the plane. So maybe like that, and then shade it in. So you won't see the y-axis, but I guess you could see the z-axis, or the idea you're looking down at it. It's going up to, it's coming towards you, and it's going up to the right from the z-axis, right? There it is. One more example. And this time, it's the most complicated case. We're only going to do one. You got to get your head around it. You can make up your own if you want. It's going to go through the origin, but it doesn't go through any axis, okay? So this plane does not go, plane is not parallel or perpendicular to any plane, principal plane or axis. So this makes sketching a little more, a little more fun, I guess you could say. You can't just do intercepts. I mean, it goes through the origin, great, but now what? The way to do it is to find points in either the XY plane, the YZ plane, or the XZ plane. So for this one, I'm choosing a point, let's do the XZ plane. So that means y is equal to 0. And I'm looking at 3. So I end up with, when y is 0, I have 3x minus 5z is equal to 0. And so when I look for a point, I know y is 0. I need something that works out for multiples of 3 and 5, which is 15 is the lowest one. So 5 and 3. Okay. I'll also do a point on the, and you get to choose. In this case, I think it's maybe easier to do one on the YZ plane. You have to try it out till you get a feel for it, maybe. X is equal to 0. So now our equation is 4y minus 5z is equal to 0. That means the point is 0, 4 and 5, so 20, right? So 5 and 4 are part of this plane. Now, what do we do with that? Well, we have to plot these points. And, up till now, we've been plotting points and vectors by drawing rectangular prisms. And I hope you've gotten comfortable visualizing this, because we're not going to do the prisms now, because we're trying to draw this plane and the prisms would get in the way. So I'll draw the first one, 5. So to me, 5, neither left or right, but up 3 spaces. So 1, 2, 3, right about here. So that is the point 5, 0, and 3. X is 0, and then 5 spaces right, so right about here maybe, and then up 4 places, so maybe here. Okay, so I'll label that. So I've roughly graphed these points. Now, how do we draw the plane? Well, we connect those points to the origin. And what we're showing, this line I'm drawing, is part of the intersection of the plane with the YZ plane, and partly with the plane we're trying to draw, where it intersects the XZ plane. So it's like it's cutting through the walls, those principal planes or walls. Where does the plane we're trying to draw cut through those walls or those planes? Now, we still have to show an edge. So what we usually do is connect those ends of those lines and sketch it in. And this has the worst visualization and representation of all the sketches. It doesn't look quite right. Maybe if you squint at it, it does. So this plane, as it's moving away from you, is falling down as it moves away, and it's falling down as you move to the left. Okay, so it's coming up into the right as it comes towards you. It's going up to the right. It's going up as it comes towards you, and even more up to the right as it's coming towards you, as you go to the right as well. So that's sort of the idea. Okay. Good luck with your sketching.